Hi, this is Jason Molesky. In this example, we'll take a look at how we can find the probability of at least one event occurring. Many people who come to clinics to be tested for HIV don't come back to learn the test results, so clinics now use rapid HIV tests that give a result while the client waits. The trade-off for these fast results is that rapid tests are less accurate than slower lab tests. Applied to people who have no HIV antibodies, one rapid test has a probability of about 0.004 of producing a false positive, that is, falsely indicating that antibodies are present. So, if a clinic tests 200 randomly selected people who are free of HIV antibodies, what's the chance that at least one false positive will occur? Well, it's reasonable to assume that the test results for different individuals are independent, which means we can use the multiplication rule for independent events. We have 200 independent events, each with a probability of 0.004. At least one combines many possible outcomes. We could have one person who has a false positive, or two, or three, all the way up through all 200 having a false positive. So it'll actually be easier to use the fact that the probability of having at least one positive is the same as 1 minus the probability of no positives. They're complements of each other. So the probability of a negative result for any one person is the same as 1 minus 0.004 or 0.996. To find the probability that all 200 people have negative results, we can use the multiplication rule for independent events. Again, remember, we're trying to find the probability that nobody gets a negative result. Therefore, we'll find the positive that all 200 are negative by multiplying 0.996 times 0.996 times 0.996 200 times. Or written a little more compactly, 0.996 to the 200th power, which is 0.4486. Now the probability we want is actually 1 minus 0.4486. We want the probability of at least one positive, which is 1 minus the probability of all negatives. 1 minus 0.4486 is 0.5514, or 55.14%. So, there's more than a 50% chance that at least one of the 200 people will test positive for HIV, even though no one has the virus. For some additional practice with problems like these, try exercise 91.